We're going to be working with some compound inequalities, which means we're joining two inequalities into one solution set. And you can see here we have one example, and it's an OR, so this one says OR. Then over here I have one similar setup, except the only thing I changed was the word AND. So there's two different things you're looking for when you're doing a compound inequality that has an AND versus an OR. So this is important for this type of a topic. So I want to go over these two graphs. So notice that you have x is less than 1, x is greater than or equal to 3. And over here is x is less than 1, x is greater than or equal to 3, except that this is joined by the word and this is joined by the word or. So those two words describe the relationship that they are looking for in terms of their solution set. So what I'm going to do is I'm going to graph this solution set for this one here. And I want you to see how I set it up. So whenever they tell you to graph a compound inequality with the word or, that means they want you to provide both solutions on the same graph. So you're basically combining them. You're going to join them together. So I'm going to put down my two numbers. Let me just fix that. So I'm going to put the 1 and the 3. So those are the endpoints I'm interested in. And I'm going to do this first one here in red. So I have any numbers less than 1 is a solution. So that means I'm going to use an open dot on the 1, and I'm going to shade to the left. And I'm going to shade this in to say that that goes on forever in that direction. So here's my first solution set, all numbers less than 1. And the other solution set is all numbers greater than or equal to 3. So I'll do this one in green. All numbers greater than or equal to 3 means I'm going to include the 3, and I'm going to shade to the right. So all numbers greater than or equal to 3 will be to the right. And you can see here that these are both solution sets combined onto the same graph. And that's what you're doing with OR. You're just going to combine these onto the same graph, and that's it. So this is actually my final answer. So these are all the numbers that are either less than 1 or greater than or equal to 3. So any of these numbers that I pick has to satisfy at least one of these solutions. So if, like, for example, I picked the number 4, then 4 is bigger than 3, it will be true in this case. Even though it's false in this one, it's fine. It has to be true for at least one of these two inequalities. So any number you pick has to be true for at least one. And you can see between 1 and 3, for example, I would have the number 2, right? The number 2 is here. If I were to put 2 in place here, 2 is less than 1 is false, right? It's not smaller than 1. And if I put it here, 2 is not bigger than 3 or equal to 3, so it's also false. That's why that is not a solution, because it has to be true for at least one of them. Now for this inequality, I'm going to draw my number line. And I recommend that if you don't have like colored pencils, you can draw 3 graphs. You can sketch them all 3 stacked on top of each other. So this is how I do it usually. So I have 1 and 3. Those are my endpoints I'm interested in. 1, 3, 1, 3. So just make sure these are all lined up. Again, I got those numbers from here, the 1 and the 3. I'm going to graph x is less than 1 for this one here first. I'm going to graph x is greater than or equal to 3 in this line. And then I'm going to do both of them together on this one. So I'm going to combine both of these on the final graph. So I'm going to show you what they're looking for here. So for x is less than 1, I'll do this one in red. All numbers less than 1, we know it's going to be open dot here and shade to the left. So that's my solution set for the first one. And then for the second one, all numbers greater than or equal to 3, that's going to be on the second graph here. We're including the 3. Shade to the right. And now, the final solution set. So again, these are sketches of each one, but and is asking us to find the intersection of these two graphs. Where do they overlap? And one way you can think of it is like if you think of like 3 different sections here. Right, this will be my section 1, the middle is section 2, and the middle is section 3. So you just ask yourself, is there a section where they both have solutions? So in section 1, we only have solutions here, but there are none here. Section 2, we don't have any solutions in either graph. And in section 3, we have solutions for this graph here, but not for this one. And is looking for solutions in both cases, but we don't have it in both cases here. Therefore, there is no solution for this one. There is nothing they have in common. So this one would actually have no solution. And I would put that down here. So I'll put no solution. And I'm just going to redo this graph on a single one with the color so you can see we're looking for an overlapping region. So let me just show you that real quick too. I'm just redrawing it so you can see numbers less than 1 would be like this. Right? We said it was going to go to the left. Numbers greater than or equal to 3, I'll do it in green. So going this way. And you can see that these two graphs do not cross paths. So these do not have a common solution. There is no number. Another way to think of it, there is no number that's going to be smaller than 1 and also bigger than 3 at the same time. It's not possible. If I pick a number less than 1, like 0, it will be true for this one, but it'll be false for that one, right? 0 is less than 1, but it's not bigger than 3. If I pick any numbers between here, like 2 is less than 1 is not true, but it is not true for this one either, actually. So 2 is less than 1 is false. 2 is greater than 3 is actually false as well. So that would not be true for either case, which is why it's empty. And then for a number bigger than or equal to 3, like 4 is less than 1 is false, and 4 is greater than or equal to 3 is true. But it has to be true for both. So there is no number that will be true for both. It'll be true for either one, or it'll be false for both. But it will never be true for both. And that's why this has no solution. Now we're going to look at two more inequalities. So again, it's an or and an and. Except in this case, in the previous example, it was x is less than 1. But now I made it so that the values of x have to be greater than 1. And in the previous example, it was values of x greater than or equal to 3. But now I switched it so that the values have to be less than or equal to 3. And that's going to change things around a little bit. So I'm going to show you the graph, what it looks like. That way you can pretty much get an idea of all the different types of possibilities you're going to work with when you're solving these compound inequalities. So what I'm going to do first, I do a sketch of the graph. So we have 1 and 3 here. So now in this case, all numbers greater than 1. I'm going to put this one in red. Greater than 1 would be open dot. And I'm going to shade to the right. So these are all the numbers greater than or equal to 1. Just greater than 1. So that's the first one here. And next, numbers, I'll do this one in green. Numbers less than or equal to 3 would be a solid dot on the 3. And it's going to be shaded to the left because numbers less will go to this direction. So now I do this. So you can see that in this case, the entire number line is actually covered. So just so you can see what I mean, like my final answer that I'll put, I'll just do it in purple. So you can see that basically every single number is taken care of. So it means any number you pick will be true for at least one of these inequalities. So you can see that they cover each other. They cross paths and they cover the entire number line. So nothing is left untouched. So again, for or, you're looking at further, any number you pick has to be true for at least one. And here's like an example of what I mean by the truth. So it could be like true for this one and false for that one. Or it could be false for this one or true for this one. It has to be true for at least one of them. And you'll see that no matter what, when you pick a number, it will always be true for at least one of these inequalities. So that's what this graph is letting us know. Now looking at the same situation, except that in this case now, we're going to be using the word and means you're looking for the intersection. So look here, I'm going to draw my sketch again, and I'm going to stack these up like last time so you can see what I'm looking for when I say the word and, because and again is looking for the intersection of these two graphs. So this is a good way to do it. So numbers greater than 1, I'll put on this graph. Then numbers less than or equal to 3 will be on this graph. And then I will combine them together on this graph right there. So that will be my setup. So let me just fix this. So less than or equal to 3. So again, I'm going to grab this first one. I'll do this first one in red on this here. So let me just change this, I guess, so you can see that we're going to graph this one is here. The second one, I'm going to do it in green. So that will be here in green, less than or equal to 3. And then in purple, I'll combine them together. So and would be the combination of the two. So that's how I'm going to set this one up. And for the first one, numbers greater than 1 will be like this, open dot, shaded to the right, and then shade that in. So these are all my solutions, bigger than 1. And then for the next one, numbers less than or equal to 3 will be a solid dot, shaded to the left. And I'm going to shade that in here. And then for the last one, and is saying, what solutions do they have in common? And you see where the endpoints are that I drew? I'm just going to draw like an imaginary line here. So this imaginary line lets me see that there's actually like 3 sections. 1, 2, and 3. So I have the section down the left, down the middle, and on the right. And is asking you, which section do they both have solutions in? So if I look at the first section, there's no solutions here, but we do have solutions here. So again, for and, we need solutions in both, but we don't. So this one will not be on the final graph. Section 2, we have solutions in the middle. You can see these are all solutions. We also have solutions here. So that means that we will have solutions on the final graph here. So I'm going to shade this in because this section, they both have solutions. And again, that's what and is looking for. The common numbers, they both have solutions. And then section 3, we have solutions here, but there are no solutions here, which means nothing is going to go on the final graph. And the only other thing I got to take care of now is we want to check out what the endpoints are. So you can see the endpoint here is open dot, which means we're not including it. Here we do have a solution. And remember, and is looking for a solution for both of them. So this one will be empty because they both don't have a solution at the value 1. And then here at 3, this is filled in. So we know there is a solution at 3. 3 is a solution for that set. 3 is also a solution for this set, which means 3 will be a solution for this one as well. So again, and is looking for the numbers that will be true in both cases. So for and, you have to pick a number that will be true here. And you also have to pick a number that will be true here. And it'll be true in both cases whenever you pick numbers that are bigger than 1, not including it, but bigger than 1 and less than or equal to 3. So anything in between, you could pick the 3 or the 1, and it'll be true for both inequalities up here. And that's what the graph allows us to do. It allows us to see all the possibilities very quickly for these two inequalities.